Now let us continue with the areas of parallelogram. Is it okay with you?
Yes, ma'am.
Areas of parallelogram. So I'll show you NIT video. We'll continue from where we left off. 1 minute, I'll share my screen. Can you see?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So here, we had done all three, no? Areas of parallel triangles also we did. Isn't it?
Recall that two figures are
You have done this, right? Areas of triangles. Did you work out the problems?
Yes,
let's
ma'am.
find. Now, let's prove that triangles on the
Got it?
same base and between the same parallels are.
You got it?
Yes, ma'am.
Till the exercise we had done, no? 3 questions I gave you. So this ABCD is a parallelogram. Area is 120, and then L and M are midpoints. You have to draw the figure. What will be the area of AMLD?
60, ma'am.
So you have found out that, and then show that line segment joining the midpoints of pair of opposite sides of a parallelogram divides the parallelogram into two parallelograms of equal area, and then ABCD, ABPQ are two parallelograms. R is a point on AQ. Prove that PRB equal to half area of ABC. So this is where we stopped yesterday. Shall we continue?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Here are the answers.
So here they have given the answers. Do you want to check the answer?
Yes, ma'am. Yes,
One minute.
Yes, ma'am.
1 minute.
Here are the
So 60, and then they have given a hint. They have not given the answer. Here quadrilateral AEFD and EBCF are parallelogram. How can you say they are parallelograms?
DF is parallel to AE, ma'am. DF equal
And
to AE, ma'am.
correct. So they are also parallelogram. So they will be equal in area. Now in third question, triangle and a parallelogram on the same base and between the same parallels, then area of triangle is half the area of the parallelogram. So triangle area of PRB is half area of
QPBA, ma'am.
QPBA, and the area of QPBA equal to?
ABCD parallelogram, ma'am.
Correct. So we can say that area of PRB is half of area of ABCD. No?
Yes, ma'am.
So let us see what they have got in the next topic.
Recall that two figures are said to be on the same base and between the same parallels if they have the common base and the vertices opposite to the common base of each figure lie on a line parallel to the base. Here we have two triangles, ABC and DBC. These lie on the same base, BC. And between the same parallels, AD and BC. Let's find the relationship between two triangles that lie on the same base and between the same parallels. Here, AB is parallel to DC. Now consider two triangles, ADC and BDC, that lie on the same base DC and between the same parallels AB and DC. Observe that the triangle ADC overlaps the triangle BDC completely. Hence, triangles ADC and BDC are congruent. Therefore, the area of the triangle ADC is equal to the area of the triangle BDC. Now, let's prove that triangles on the same base and between the same parallels are equal in area. It is given that two triangles, ABC and DBC, are on the same base BC and between the same parallels FE and BC. We need to prove that the area of the triangle ABC is equal to the area of the triangle DBC. Draw BF parallel to CA through B, intersecting DA produced in F. Also, draw CE parallel to BD through C, intersecting AD produced in E. Let's start with the proof. By construction, BF is parallel to CA, and it is given that BC is parallel to FA. Since both pairs of the opposite sides of the quadrilateral BCAF are parallel, it is a parallelogram. Similarly, the quadrilateral BCED is a parallelogram. Now, both parallelograms lie on the same base BC and between the same parallels FE and BC. Therefore, the area of the parallelogram BCED is equal to the area of the parallelogram BCAF. Denote this as equation 1.
What do you think will be the next step? What do you think is the next step?
Area of
BC
triangle ABC equal to half of parallelogram FACB, ma'am.
Huh.
And
So,
also
and
area of
also,
triangle BDC equal to half of parallelogram BDEC, ma'am. So they are equal.
correct. Another way is you can draw height perpendicular and prove.
We know that a diagonal of a parallelogram divides it into two triangles of equal area. Therefore, the area of the triangle ABC is equal to half the area of the parallelogram BCAF. Denote this as equation 2. Similarly, the area of the triangle DBC is equal to half the area of the parallelogram BCED. Denote this as equation 3. Hence, from equations 1, 2, and 3, we get that the area of the triangle ABC is equal to the area of the triangle DBC. Now we will prove that the area of a triangle is half the product of any of its sides and the corresponding altitude. It is given that in the triangle ABC, AD is the altitude to the side BC.
What is the
We
other
need to
name for
prove that the
altitude?
area of the triangle ABC is half the product of the base BC and the altitude AD. Through C and A, draw CE parallel to BA and AE parallel to BC, respectively, intersecting each other at E.
What is the next step? How will they prove? Area of ABC is half into BC into AD.
Ma'am, area of parallelogram is half into. Ma'am, area of parallelogram is base into height, ma'am. And
Huh.
AC act as a diagonal in parallelogram ABC, ma'am.
Huh.
And the diagonal of the parallelogram divides it into two congruent triangles having equal areas, ma'am. So the area
Correct.
of triangle ABC is equal to half of the area of ABC, ma'am.
So what is the formula for this thing? Base into height. Height is the same, right?
Yes, ma'am.
Here, by construction, BA is parallel. Now, let's prove the theorem that states that if two triangles have equal areas and one of the sides of one triangle is equal to one of the sides of the other, then their corresponding altitudes are equal. It is given that in two triangles ABC and DEF, the area of the triangle ABC is equal to the area of the triangle DEF, and BC is equal to EF. We need to prove that altitudes AM and DN are equal.
How can you prove? What is the area of ABC?
BC into AM, ma'am.
No. How
Half
BC into
into
Half
BC
AB?
of
into A,
BC
ma'am.
into AM, ma'am.
Half into BC into
AM, ma'am.
area of DEF?
Half into
Half
EF into
into
DN.
EF into DN, ma'am.
BC equal to EF given and areas are equal. Therefore,
AM is equal to
AM
DN.
equal to DN, ma'am.
correct.
In the triangle, two triangles having the same base or equal bases and equal areas have equal corresponding altitudes. This implies that two triangles lie between the same parallels, because in order to have equal corresponding altitudes, the triangles must lie between the same parallels. Now, using the formula for the area of a triangle, we will prove that the area of a trapezium is half the product of its height and the sum of its parallel sides. The trapezium ABCD is given, in which AB is parallel to DC and CN is perpendicular to AB. We need to prove that the area of the trapezium ABCD is equal to half the product of its height h and the sum of its parallel sides AB and DC. Join AC and draw AM perpendicular to DC.
So how can you prove? What is ANCM?
Ma'am, rectangle.
Rectangle, ma'am.
So what is the area of ABC?
Half of AB into CN, ma'am. Half of
What is the area of ADC? ADC?
Half of DC into AM, ma'am.
DC into AM, ma'am.
Correct. Now if I want ABCD, I have to add them. So half of AB into H plus half DC into H, correct?
Yes, ma'am.
Yes, ma'am.
What is common there?
Height is common, ma'am.
Half and H.
Half and H common. So if you remove the common, you will get AB plus DC, correct?
Yes, ma'am.
Yes, ma'am.
Yeah.
Here, let's consider some illustrative examples. Example 1. Diagonals AC and BD of the trapezium D with AB parallel to DC intersect each other at O. Prove that the area of the triangle AOD is equal to the area of the triangle BOC. It is given that diagonals AC and BD of the trapezium ABCD with parallel to DC intersect each other at O. We need to prove that the area of the triangle AOD is equal to the area of the triangle BOC.
How can you prove?
Ma'am, can I?
Ma'am,
Yes,
the
yes.
bases are
Ah.
equal
Area of
and
triangle
they lie
ADB, ADB equal to area of triangle ACB, ma'am. They have
Ah.
same base and lie between same equal parallels.
Correct.
Area of triangle ADB means area of triangle AOD plus AOB, ma'am. And again,
Correct.
area of triangle ACB means area of triangle AOB plus COB, ma'am.
Correct.
So AOB get cancelled, ma'am. AOD equal to COB, ma'am.
Correct. Excellent. Very good.
Here, AB. Example 2. Show that a median of a triangle divides it into two triangles of equal area. The triangle ABC is given, in which AD is the median. We need to prove that the area of the triangle ABD is equal to the area of the triangle ADC. Draw AE perpendicular to BC.
How can you prove? What is the area of ABC?
Ma'am, half into
Half of
AD
BC
ma'am.
into AD, ma'am.
ma'am.
Half of ABD, ma'am.
What is the area of ABD?
Half
Half
of
of
AD
AD into
ma'am.
AD, ma'am.
To AD ma'am.
And ADC?
Half of DC into AE, ma'am.
Correct. And BD equal to?
DC, ma'am.
ma'am.
B. So area of ABD will be equal to area of
Area of
ADC.
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 Correct? Yes?
Yes, ma'am. Yes, ma'am. Yes,
Ma'am.
In the example 3, AD is one of the medians of the triangle ABC and X is a point on AD. Show that the area of the triangle ABX is equal to the area of the triangle ACX. It is given that AD is one of the medians of the triangle ABC and X is a point on AD. We need to prove that the area of the triangle ABX is equal to the area of the triangle ACX. We know that the median of a triangle divides it into two triangles of equal area. Now, AD is the median of the triangle ABC. Therefore, the area of the triangle ABD is equal to the area of the triangle ACD. Denote this as equation 1. Similarly, XD is the median of the triangle BXC. Therefore, the area of the triangle XBD is equal to the area of the triangle XCD. Denote this as equation 2.
What is the next step?
Ma'am, subtracting
Ma'am,
both
we
the
have to
subtracting equation 1 and
subtract the equation 1 in equation 2.
2 in 1, ma'am.
Correct. 1 minus 2, right?
Yes, ma'am.
Equation 1 minus equation 2, you will get the answer.
Now, example 4. In the given triangle ABC, D is the midpoint of AB and P is a point on BC. CQ is drawn parallel to PD to intersect AB at Q and PQ is joined. Show that the area of the triangle BPQ is equal to half the area of the triangle ABC. It is given that in the triangle ABC, D is the midpoint of AB, P is a point on BC, and CQ is parallel to PD. We need to prove that the area of the triangle BPQ is equal to half the area of the triangle ABC. Join CD.
How can you prove? BPQ, half area of ABC. Which are the lines parallel?
CQ and PD, ma'am. CQ and PD, ma'am.
CQ and PD are parallel. So which area, which two triangles will be same, having same area? Which two triangles will have same area?
Ma'am,
PD
triangle
plus
CQ, CQP
PQD,
and
PQD. Correct.
yes, ma'am. Yes, ma'am.
Then after that, you want BPQ. How to get BPQ?
Ma'am, triangle
Huh.
equal to DCA, ma'am.
DCA. How? How?
Ma'am, because D is the mid. D.
D is the midpoint of AB. So CD is the median. Correct?
Yes, ma'am. Yes, ma'am.
CD is the median. So area of BDC equal to area of ADC.
Yes, ma'am.
Correct. Now, area of ADC, you have to get BPQ. You are saying area of DBC, right? Not ADC, DBC, no?
DBC,
Correct?
ma'am.
Yes,
Yes,
ma'am.
ma'am.
DBC. Now we need BPQ there, DBC. So DBC area equal to ADC. If you add DQP, you will get BPQ, no?
Yes, ma'am.
Yes. And you can add for ADC, DPQ equal to DPC. But what is the use? What will you get? DPC, if you add DPC to ADC, you will get ADPC. We want ABC. Are you working out?
Yes, ma'am.
Try. You have to prove area of BPQ is half area of ABC. Your observation that CD is the median, that is very good, very useful. Got it? No? Hello?
Triangles
No, ma'am.
DPC and DPQ are on the same base DP and between the same parallels DP and QC. Therefore, the area of the triangle DPC is equal to the area of the triangle DPQ. On adding the area of the triangle BDP on both sides, we get that the area of the triangle BCD is equal to the area of the triangle BPQ. Denote this as equation 1. Now, in the triangle ABC, CD is the median. Therefore, the area of the triangle ACD is equal to the area of the triangle BCD because the median of a triangle always divides it into two triangles of equal area. But the sum of the areas of triangles ACD and BCD is equal to the area of the triangle ABC. Substitute the area of the triangle ACD with the area of the triangle BCD. This implies that twice the area of the triangle BCD is equal to the area of the triangle ABC. Thus, the area of the triangle BCD is half the area of the triangle ABC. Denote this as equation 2. Hence, from equations 1 and 2, we get that the area of the triangle BPQ is half the area of the triangle ABC.
Here, BCD is half area ABC. Correct?
Yes, ma'am.
Yes, ma'am.
Now, what they are saying is BCD equal to BPQ. You agree? Area of BCD equal to area of BPQ. Do you agree? Do you agree? No? Yes or no?
Yes, ma'am.
BCD, area of
Yes, ma'am.
BCD equal to area of BPQ. How? How? BCD equal to BPQ. How? How
Ma'am,
much?
area of
What?
triangle DPQ is equal to area of triangle DCP, ma'am.
Ah. So that is why you add it, no?
Yes, ma'am.
BDP, we want BPQ. How to get BPQ? BDP plus
DPQ, ma'am.
DPQ. Correct? And
Yes, ma'am.
DPQ equal to DPC. BDP plus DPC is BDP plus
BDC.
DPC. BDC. So BDC equal to BPQ. Correct? Yes or no?
Ma'am.
Yes, yes,
Yes.
ma'am.
And we know that BCD is half of ABC. So BPQ also will be half of ABC. Correct?
Yes, ma'am.
Example 5. The medians BE and CF of the triangle ABC intersect at G. Prove that the area of the triangle GBC is equal to the area of the quadrilateral AFGE. It is given that the medians BE and CF of the triangle ABC intersect at G. We have to prove that the area of the triangle GBC is equal to the area of the quadrilateral AFGE. Join FE.
How to prove? GBC equal to AFGE. BE is the median, CF is the median. Area of ABE equal to
Area of BCE, ma'am.
and area of BFC equal to
Area of
area of
ACF.
ACF. That much we know. How to get BGC from BEC? How to get it? Now F is the midpoint of AB, E is the midpoint of AC. Therefore, EF is
Half of BC.
and also
Parallel to BC.
Parallel to the
parallel
BC.
to BC. So area of BFE equal to area of BFE equal
Area
to
of FEC, ma'am.
EFC. Correct?
Yes,
Ma'am.
ma'am. Yes, ma'am.
And also BEC equal to BEC
AEB, ma'am.
BFC, no? BEC equal to BFC. Correct?
Yes, ma'am.
Using all this, we can prove.
Proof. Since F and E are the midpoints of AB and AC, E is parallel to BC by the midpoint theorem. Now triangles EBC and FBC are on the same base BC and between the same parallels FE and BE. Therefore, the area of the triangle FBC is equal to the area of the triangle EBC. Subtract the area of the triangle GBC from both sides. We get that the area of the triangle FGB is equal to the area of the triangle EGC. Denote this as equation 1. Now in the triangle ABC, CF is the median. Therefore, the area of the triangle BCF is equal to the area of the triangle ACF because the median of a triangle divides it into triangles. Denote this as equation 2.
Did you understand this?
Yes, ma'am.
So, area of FGB equal to EGC, BCF equal to AEC. Sorry, ACF, not AEC, ACF. Correct? Hello?
Subtract equation 1 from equation 2. We get that the area of the triangle GBC is equal to the area of the quadrilateral AFGE.
Did you understand?
Yes, ma'am.
Yes? Subtracting. Okay?
Example 6. The side AB of the parallelogram ABCD is produced to point P. A line through A parallel to CP meets CB produced in point Q, and the parallelogram PBQR is completed. Show that the area of the parallelogram ABCD is equal to the area of the parallelogram BPRQ. The parallelogram ABCD is given in which the side AB is produced to point P and AQ is drawn parallel to CP so that PBQR is a parallelogram. We have to prove that the area of the parallelogram ABCD is equal to the area of the parallelogram BPRQ. Join AC and QP. Since AC is a diagonal of the parallelogram ABCD, the area of the triangle ABC is half the area of the parallelogram ABCD. Denote this as equation 1.
So, what is the next step?
In parallelogram QRPB, triangle QRP is equal to half of area of QRPB, ma'am.
Correct. And then we have to prove the area of ABCD is equal to area of BPRQ. Area of ABC is half area of ABCD and area of BPQR is area of BQP is half area of BPQR. Now, how is the line CP, how are the line CP and AQ?
They are parallel, ma'am.
They're parallel. So, therefore, AB parallel to DC, BP parallel to DC. What do you get from that? What do you get from that? Area of ABC is half area ABCD, area BPQ, half area BPRQ. CP parallel to AD. Not getting?
Also, PQ is a diagonal of the parallelogram BPRQ. Therefore, the area of the triangle PBQ is half the area of the parallelogram BPRQ. Denote this as equation 2. Now triangles AQC and AQP are on the same base AQ and between the same parallels AQ and CP. Therefore, the area of the triangle AQC is equal to the area of the triangle AQP.
What is the next step? AQC.
ABC equal to QBP, ma'am.
So, therefore what?
Area of parallelogram ABCD is equal to parallelogram
Equal to area of parallelogram BPRQ.
See here, from AQC equal to AQP, what did you say is the next step? AQC equal
ABC equal to
ACB
BQP,
is equal to BPQ.
to BPQ. So 2 times that will be ABCD and BPQR, BPRQ, correct?
Yes, ma'am.
Ma'am.
Correct.
From equations 1 and 2, we get that half the area of the parallelogram ABCD is equal to half the area of the parallelogram BPRQ. Hence, the area of the parallelogram ABC is equal to the area of the parallelogram BPRQ. Now, try these questions and check their answers on the next page.
Can you take a screenshot?
Yes, ma'am.
Try this. I will also share it in WhatsApp. 2 questions. Okay, I have shared the question.
Here
Try it.
are the hints.
Okay, so let us do some quiz now. We have finished all the chapters now here.
Yes, ma'am.
Yes, ma'am.
So here this one Aishwarya has to answer. Aishwarya,
Yes, ma'am.
please answer this question. If a parallelogram and a trapezium are on the same base but not between the same parallels, then
Ma'am, D option.
is not equal. Okay. Next is Akash. Akash.
Yes.
Akash,
Yes, ma'am.
please answer this question, please. ABCD is a rectangle. AB is 16. AD is 10. What is the area of ABEF? Akash,
Third option, ma'am.
third option. So the rectangle
That's
is also
correct.
a parallelogram. Anjali,
Yes, ma'am.
Anjali, answer this. AB parallel to HD, HD parallel to GE, AG parallel to BF and parallel to DE. AG is perpendicular to GE, BF is perpendicular to GE, DE is also perpendicular to GE. Find out the relation between the areas of rectangle HCFG and HGED. HCFG and HGED. They are equal or they 3 times or 2 times or not equal.
Option 1, ma'am.
Option 1.
Option 3, ma'am.
Sorry. 3, ma'am. Option 3, ma'am.
Oops, that is incorrect.
Option D, ma'am.
D, ma'am.
That's correct.
Bhumika,
Yes, ma'am. Please explain this one.
Bhumika, you have to answer this question. Which is the correct option? Here AG is 2 and AF is 3. But they look equal, no? Like a square they look, isn't it?
Yes, ma'am.
You have to find, what is this? Find out the relation between the areas of the rectangle AE,
J-I, ma'am.
JI and AEDB. AEJI, AEDB. What is the relation?
Ma'am, option 3, ma'am.
Area of rectangle is greater than?
Oops, that is
Ma'am,
incorrect.
option. Ma'am, option C.
What's the answer?
Option C, ma'am.
Ma'am, option C. Option C, ma'am.
Option C.
That's correct.
Now next. Danaya,
Yes, ma'am.
you have to answer this. ABCD is a parallelogram, AB is a triangle. AB, area of AB equal to dash.
Option B, ma'am.
Option B.
That's correct.
Next, Farhan has to answer. Farhan is there?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
You have to answer, Farhan. A farmer has a field in the form of a parallelogram PQRS. He takes any point A on RS and joins it to points P and Q. You have to draw a parallelogram, name it as PQRS, take any point on RS, name it as A, and join it to P and Q. What is your answer? Area of ASP equal to APQ, ARQ equal to APQ, which is the correct answer.
Option D, ma'am.
Option D.
That's correct.
Madhumika,
Yes, ma'am.
you have to answer this. P and Q are points on DC and AD. What is area of APB equal to? Madhumita,
Yes, ma'am. Option A, ma'am.
option A, BQC. Mahalakshmi,
Yes.
you have to answer this. O is a point in the interior of parallelogram ABCD. PQ is drawn parallel to AB. Area of AOB plus area of COD equal to
Ma'am, half of the area of parallelogram ABCD.
third option.
That's correct.
Mahantesh.
Yes, ma'am.
Answer this. PQRSPABC are two parallelograms. Then area of PQRS is 2 times area of
Yeah, option A.
Which one?
D option, ma'am.
Which one? D. Next, Naveen. 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 Is it there? Naveen.
Yes, ma'am. Yes, ma'am.
You have to answer this. Find the area of the given parallelogram.
Option A, ma'am.
Okay. Option
A, ma'am.
C.
Option A, ma'am.
A.
That's correct.
Pavan.
Yes, ma'am.
Last question. Last question for the day. Find out the area of a parallelogram whose base is 29 and altitude 20.2.9.
Option C, ma'am.
C.
That's correct.
Correct. So time is up. Next time we have come up to Pavan. After Pavan, whoever is there has to answer in the next class. Is that okay with you?
Yes, ma'am.
Okay, ma'am.
So shall we end today's class?
Yes, ma'am.
Bye. Good night. See you on
Thank you,
Friday.
ma'am.
Good night, ma'am.
Good night, ma'am.
Good night, ma'am.